Why? So that it will aid in analysis to handle any question or problem involving projectiles. We have derived the equations, but there are some intrinsic things that they are not mentioned, but they are already in the equations. Let's start with this. Right from the beginning again. We know V. We will resolve it into V cos theta I plus V sin theta j. Where theta is the direction. If it is in a vector form, so we have it like this, V theta. So Vx or horizontal is V cos theta. Vy, that is V in the vertical direction, is V sin theta. Then we also noticed that in this instance, Ax is 0, Ay is minus G, depending on how you want to look at it. But most times we use minus because we always propel the projectile upward. So acceleration due to gravity is downward. So when we notice this, we also know that when it gets to the highest point, it will start turning down. The time to get to the highest point, time for h max, we derive that to be Vy over G. That is V sin theta over G. The time for it to go up and come down, if it is on the same level, if it is like this, that is this place and this place are on the same level. So the time for flight will be equal to 2V sin theta over G. We derive that. We also noted that H max, maximum height, is equal to V square sin square theta over 2G. So you can easily say V square over 2G, Vy square over 2G. You can easily say Vy square over 2G. Straight. And that makes it easy for us to assimilate. We can also say range, that is the total horizontal distance, is equal to V square sin 2 theta over G. And if you look at this, we derive it from the fact that we say V square into 2 sin theta cos theta over G. We can still break this down. You can say it's equal to 2 into V sin theta, V cos theta over G. And that will give us 2 Vy Vx over G. It gives us 2 Vy Vx divided by G. What does that imply? It makes our work easy. E.g., if we are given a vector like this, and the velocity is, let's say, 20I plus 30G. That is the velocity vector. And we are asked the range and the maximum height. You just come here, you know what your Vy is, what your Vx is. So range from here will be equal to 2 times Vy Vx over G. So if you assume it is 10, so you can see how you can solve it straight. Maximum height will be equal to 30 squared over 2G. Straight, direct. You solve your problem there. So I am just trying to see how to make it very easy for us. Now, when we have it like this, we have a projectile in this manner. So, as it is moving, the angle of the velocity will vary. Angle of velocity and velocity varies. So, vertical changes. This one is constant, but this one varies. So at any point in time, you can find what your total velocity is. So Vy at any point is equal to V sine theta, the initial v, minus gt. So v at any point, v will be equal to root of this vy at any point plus vx squared squared. So that will be your v. And the direction of velocity at any point, direction, will be equal to r tan vy over vx, because this one varies. So that's how you find your angle of velocity at every point in time. So please note this. Another thing is, we can also talk about angle of displacements. Angle of displacements. You see, this one is changing. Now, look at this. So this is the angle. Let me make this angle of displacement. Angle of displacement. So you can see, you can easily find your v, your y at this point, and your x at this point. So w will be equal to r tan y over x. So once you find this, you get your, and this one also changes with time. It also changes with time. Now let's look at another aspect, kinetic energy. Kinetic energy. Kinetic energy changes. Why? Because as it is going up, it will be losing some, it will be converting some kinetic energy to potential energy. So when it starts at beginning, O times O, Ke will be equal to half v squared. The angle does not come to play here. But when it is rising, Ke will be equal to the Ke at h plus ngh. So which means that at any point in time or at any height, your Ke will change and it will be equal to half the v at that point squared plus ngh. So with this relationship, you can easily find the height or the velocity at any point. You can easily find it. You can easily get your velocity at any point, and you can easily, if you know this one, you can easily find the height. Very interchangeable, very easy. It makes some workings very easy too. So you can incorporate this in your workings. We have talked about maximum height range. Now, let's look at impact of air resistance. At the maximum height, Ke at h max will be equal to half m v cos theta or square. You know why? Because vertical velocity will be 0 at that point. That is, Vy will be 0 at h max. So before I go on, I don't think I should bring this in. It should be 0. So we want to talk about impact of air resistance. Impact of air resistance. Air resistance means that it will impede motion. And what does that mean? It increases the deceleration in any direction. Most of the time you'll be given the value. If air, but in most cases, we are asked to ignore. We are asked to ignore air resistance. But sometimes air resistance can come into play. Don't panic. You will just use this one to reduce, just like acceleration, deceleration, just like deceleration. So it will decelerate, it will add to acceleration due to gravity and impede the motion Vx. That's what it will be. So your x will just be equal to Vxt minus half the resistance t squared. That's all. So in this place too, y will also come to be like that. That is all about impact of air resistance. Let's now look at equation of projectile and range. Now, before I go on, I want to tell you something. Ke, kinetic energy. Now let's go to equation. We have, this is our vertical distance. We say it will be u sine theta t minus half g t squared. And we also accepted that x equals to u cos theta, or let's say, okay, let me make it v cos theta t. So we want to express y in terms of x. We've done that before. Just make t the subject of the formula here, x over v cos theta. And then we substitute this for t in this equation. So at the end of the day, y equals to x tan theta minus half g into x squared into u squared or v squared cos squared theta. So straightforward, you can easily get this. Then, so y equals to x tan theta half g v squared cos squared theta. And we also know that r is equal to v squared sine 2 theta over g. V squared sine 2 theta over g. So g is equal to v squared sine 2 theta over r. V squared sine 2 theta over r. Then I can say y is equal to x tan theta minus v squared sine 2 theta over 2r times x squared over v squared cos squared theta. I can express this one in terms of vx, vy to make it easy for me, just like we have done. Or I can still. So if you look at this, it will be equal to, just for fun, we make it like this: 2 vx vy over 2r times x squared over vx squared. You know, this one is v cos theta, this one is v squared cos squared theta. So we can cancel this. We can cancel this. And then this one and this one will give me tan theta. Tan theta. Please, this one, vy over vx is equal to v sin theta over v cos theta, please. So that's how I got this term. Then we have it to be y will now be equal to x tan theta minus x squared tan theta over r, which will be x tan theta into 1 minus x over r. So when you have the range, you are given, okay, y, you can be able to find x at any point in time when you also have the angle. Whatever, this is how it is in terms of the range. Yeah, there are so many situations that can arise based on projectile. You might be given to work out hitting certain specific targets, or like goalposts, or people. Like when it is targeted, if you cross over people, with our calculation, substitution, and all these things, we can easily find this. Another situation that might be look foreign a bit to us is when it is launched from a height or from underneath the ground. When it is launched, especially from the height, it might give us some concern. Let us look at how to handle that. Now, we can have it like this. We can have it like this. And this is V. This is the angle of projection. When we have it like this, there is an initial height. Let's call this one h. We can calculate the time it will get to this point, or to different height level. The only thing is, I have said it is just picking our reference. You can say this place will be your 0, 0, and this place will be h. Or you can say this place will be your 0, 0, and this place will be minus h. And that will assist in handling the problem. Let's look at this. If this place is taken as my 0, 0 point of reference, this place, for me, some other people might take it as positive. But for me, because I am taking my acceleration due to gravity to act against it, in this instance, I will take this one as minus g. So if this one becomes minus g, this one too will be minus h. I hope that's clear. So I will just substitute it into the equation, like y equals to u sine theta into t minus half g t squared. So if I want to do this, I just say this minus h. If I want to find the time or anything or x at this point, I just say minus h is equal to t into u sine theta minus half g t squared. So you can see minus. So I have my t, and then I'll be able to solve everything using equation, quadratic equation, formula, or whatever. And I can also get x either by saying, after getting t, v cos theta times t, or by using this equation, y equals to x tan theta minus half g x squared over cos squared u squared cos squared theta. You can do anything. So there is no need to panic when you face this kind of situation. You get it straight. And sometimes you can have it like this. The projection might come down like this. It can come down like this. So you can see. So in this instance, I can decide to say, okay, since it is coming down, the velocity is facing down, this place will be positive to me. In that instance, I just want you to know the difference. That's why I said, just know what you are doing. Take your reference, and then all the necessary senses, take it in the right way. So if my velocity downward, if I take my velocity downward as positive, my g will be positive this time around. And then this one will come down like this. You can see. And that solves it. It makes it easy. And this instance, h will also be positive in that instance. So there is no point to panic when you face this kind of situation. Projectiles is very, very easy and fun. Before I go on, I want to say something about R. Range. You know, we said is equal to u squared sine 2 theta over g. R max will occur. We use differentiation in the other time to show that. When sine 2 theta and is equal to 1, that's the maximum value you can find for an angle. So theta is equal to 45 degrees. So that is when you can have R max. That's when you can have R max. In this instance, when theta is equal to 45 degrees. But for this R, you can have same R range for two angles with same velocities. The same velocity. How? If you look at this, sine 2 theta is also equal to sine 180 minus 2 theta. You know, in our trigonometric this thing. So, which means that in this instance, same range will have the same range when our angle is theta or 90 minus theta. That is 180 minus 2 theta over 2. So, you know, when we have theta, when the angle of projection is theta, when the angle of projection is theta or 90 minus theta. Now let's look at projectile on inclined plane. Inclined plane. We have something like this. And we are launching a projectile like this. V. And this one. We have this one. You see? And this is our normal y and x axis. For us to solve this easily, we can resolve it along the inclined plane, or we can do it along our normal x and y axis. When we resolve or work it along the inclined plane, what does that mean? It means that we are going to have to resolve it along the perpendicular to the inclined plane and along the inclined plane. So from the studies of vectors and even relative motion that we have studied before, we should be able to do this with ease. Let's see what we can do about it. So this is what it will look like. This is how our view will go. This is the new axis. Our new axis, this is our new x-axis and our new y-axis. We have treated something like this in the past. Now, our g will now have two, will now be resolved into two perpendicular values. Along the x, it will be minus g sine alpha. And along the y-axis, it will be g cos alpha. So it will come down to minus. So from there, let's see what it will be like if we now make it in our way of looking at things. So here we have theta minus alpha, and this is v. So you can see. So this is our r, and here we have g sine. Yeah, g sine. Here we have g cos alpha. So it is minus. It's acting down on our this thing. So from here we can now work things out. Please remember, we still have this one under it. So at the end of the day, we work everything out. Let's see what our vertical velocity and distance will look like. So vy will be equal to v sine theta minus alpha. Vx will be equal to v cos theta minus alpha. Please take note of that. Then our y will be equal to v sine theta minus alpha times t minus half g cos alpha into t squared. Our x will be v cos theta minus alpha times t minus half g sine alpha into t squared. Now we have gotten the equation. Let's say parametric equation for the x and y axis. Now since you are walking along this plane now, you have said it will be like this. Minus alpha. So it will be like this. With this plane, we know that at the initial stage, y equals to 0, and at the end stage, y equals to 0 along this axis. That is, y equals 0 here, y equals 0 here too. So let's see what it will be. What will be the time of touching down there? So 0 equals v sine theta minus alpha into t minus half g cos alpha t squared. Therefore, we can also factorize and say, okay, 0 equals to t into v sine theta minus alpha minus half g cos alpha t. So, which means that y equals to 0 at t equals to 0 or 2v sine theta minus alpha over g cos alpha. You can see the similarity to the normal one. So that is our t. This t, we will now substitute it in this place. We will now need to substitute it here to find our r. So r along the inclined plane. R along the inclined plane will be v cos theta minus alpha times v sine theta minus alpha over g cos alpha minus half g sine alpha times v square sine square theta minus alpha over g cos square alpha. That is our r now. So please, this one is g squared. I notice now, this one is g squared cos square alpha. So on trying to rationalize all these things, I brought 2 here so that this one will give us standard equation over 2 here again. And then I'm resolving it. Just don't want to waste your time. Now, so our r will be v cos theta minus alpha times the time here minus half g sine alpha times square of this, which is 4b squared sine square theta minus alpha over g squared cos square alpha. So on cutting, doing all the necessary listing, this is the answer I got. And then from here, you know that 2 cos theta sine theta is equal to sine 2 theta. And sine square theta minus alpha is going to give us 1 minus cos 2 theta. 1 minus cos 2 theta. So let's see what we can make out of this. Now, we have v square over g cos square alpha into cos alpha sine 2 theta minus alpha minus sine alpha, this one, into 1 minus cos 2 theta minus 2 alpha, you know. So, because this one, sine square theta minus alpha is equal to this one is equal to this. So, you can see that on expansion, this one and this one, they form another sum of two angles again. That is sine this one plus this one. This is sine 2 theta minus. So this one and this one are the same. This one and this one, as in the angles, are the same. So this one forms sine of these two angles minus sine of the sum of these two angles. And this one is separate now. So I will do this now for you. So please, this simple trigonometric identity. So we have r is equal to v squared over g cos square alpha. This one is going to be sine 2 theta minus 2 alpha plus alpha. This 2 gave this. Now minus sine alpha. So what does that give us? V squared over g cos square alpha into sine 2 theta minus alpha minus sine alpha. So now not to complicate things further, this is very simple way of expressing r across along the inclined plane. That is the maximum horizontal distance along the inclined plane. But x, if you want to find x here now, x along this place, x will be equal to r cos alpha c. And what is our y? R sine alpha. So you can find this place and this place when you have gotten r. So if the projectile comes down, this one will be negative. So it's going to be sine 2 theta plus alpha, because this one is also negative. It will also become plus sine alpha. So if it comes down, if it is projected downward, so if it is down the plane and the projectile is projected like this, to come like this, you can see that the alpha is now negative. That's what I'm saying. So the here, just impute minus alpha here, so it will be positive. Minus here again to make this place positive. So that is the r in this instance. For us to have maximum r here too, maximum r, it means that this one must be 1. That is the maximum value for sine theta. So that is when sine 2 theta minus alpha equals to 90 degrees or pi over 2 rad. Then just solve it and you get the value for theta. So that's when you have the maximum value for the range. So this one, I have done that. So in case this one comes down like this, you know how to get it along with this. That is, if it comes below, because they are measuring relative to the horizontal. What I'm saying is, if this one comes below also, like this, so our theta here will also be negative. So by the time you slot it in here, you'll be able to get your value for r. Just in case you want to resolve along the perpendicular, the normal perpendicular we always use. X equals to r cos theta, you know, this is the r in this instance. X over r equals to cos alpha, sorry, x equals to r cos alpha, x over r cos alpha, x over cos alpha equals to r. Then y equals to r sin alpha, y over x equals to tan alpha. I just want us to establish all the relationship there. But the point r is x, y. That is the point r. We know that r will be root of x squared plus y squared. That is the standard. Now, we know that this x will be u, this u, we have it here. or V, let's make it V. V cos theta, and the vertical is u sine theta. So we know this expression already in our previous listing. You know this expression, it's straightforward. Now, if you look at it, we have established that y over x equals tan alpha. Therefore, x tan alpha is equal to x tan theta minus g all over 2v x squared over 2v squared, sorry, over cos square theta. We now have it like this: x tan theta minus x tan alpha is equal to g x squared over 2v squared times 1 over cos square theta. Let's divide through by x. So it makes our work easier now. So tan theta can be expressed as sin theta over cos theta minus tan alpha over minus sin alpha over cos alpha, and that will give us this gx over 2v squared times 1 over cos squared theta. Now let's multiply. It's going to be sin theta cos alpha minus sin alpha cos theta over cos theta cos alpha, which equals to gx over 2v squared times 1 over cos square theta times 1 over cos squared theta. And if you look at this, it's an identity for sin theta minus alpha. So we have now this one, sin theta minus alpha cos square. I brought this one here, cos square theta over cos theta cos alpha. So what does that give? It gives this cancel this, and then I still retain this. I still retain that one. So this is what we have now. I brought this to here. You can see it gave us very clear identity, and this is going to be sin this plus this plus sin this minus this. So it's going to be sin theta minus alpha plus theta plus sin theta minus alpha minus theta over cos alpha, and that will give me gx over 2 over v squared over v squared. Sorry, this one has been removed. Over v squared. So it's going to be 2 sin theta minus alpha cos theta over cos alpha equals to gx over v squared. I have brought this to this side now. So it makes this one to be easy for me to handle now. So this identity now is sin theta plus alpha minus plus theta again over plus sin theta minus alpha minus theta. That's for sum of 2 sine. This identity is for sum of 2 sine over cos alpha equals to gx over v squared. Let me continue. So this one now gives sine 2 theta minus alpha plus sine minus alpha over cos alpha equals to gx over v squared. Now let's make our x the subject of formula now. So we are going to have v squared over g sin, v squared over g cos alpha into sine 2 theta minus alpha minus sine alpha, because sine minus alpha is minus sine minus alpha is minus sine alpha cos alpha is equal to v squared over g cos square alpha into sine 2 theta minus alpha minus sine alpha. So that is how. So you can add for the projectile throughout the day. Projectile is very easy and has so many ways to handle. So just pick the correct equation and make your normal substitution wherever you need to make it. That is all about projectiles. That's all about projectiles. Thank you very much. Now, before we go into some working of examples, I want us to also look at this. There are sometimes you might fire to intercept a moving projectile. You know, that one is also in motion. Sometimes you might have to target it. You might have to fire a target or horizontally or vertically. But in this instance, it's a moving body. It's like moving up or moving down. So, the knowledge of relative velocity helps in this instance. Sometimes the bodies might move from the same horizontal points, though not the same points. The vertical point might intersect, but there might be distance on the horizontal. Okay, let me see how I put it. Let's start by analyzing. Where bodies are moving, projectiles are moving. The horizontal velocities are constants. So Vax minus Vbx is constant. So in this place, it makes our calculation easy along the horizontal. But on the vertical velocities change due to acceleration. So if V A y and V B y o are initial vertical velocities, after time t, V A y t and V B y t will be the velocities after time t. Now, let us see what the velocities will be after time t. V A y t will be equal to V A y minus G t. V B y t. So V A y 0. V B y 0 minus G t. So if you subtract these two, you will realize that the relative velocities remain constant. The relative velocities remain constant. Why? Because the acceleration remains constant and in same direction. So it makes our work on intersection of projectiles very easy and straightforward. Let's look at situations that can arise. If position of A can be given as AI, AJ. Position of B can be given as BI plus BJ. If AI and BI are the same, if AI and BI are the same, but AJ and BJ differs, it means that the only point you need to consider for relative motion is the J side. Because the velocity along the what's it called? The I direction will be the same. They must be the same. But the direction, the relative velocity along BJ and AJ must follow the direction of BJ and AJ to fulfill the intersection. Let's see this example. If A is here and B, the two of them start here, are the same place, it means that for them to intersect again, they must follow the same motion throughout to intersect. That is what it means. Another thing we might say is this. Let's say BI and AI are the same. Let's say like this. Yes. But BJ and AJ, they differ. See. You can see. This is AJ, BJ. But BI and AI are the same. So, if they must intersect, it means that the velocity here must be the same. Must be the same. And relative velocity will now be along the vertical axis to now fill this place and then to intersect, because it will continue moving. As it is moving, this one will be going up. It will be going up. You know, this one continues its motion. This one also continues parallel motion like this, until at a point it will meet. So that is for this situation. In the same vein, you can have the two of them on the same plane, on the same, what's it called, J. But one must go like this and the other one must go like this. So at the end of the day, they are going to meet due to the relative velocities. So that is the intersection of projectiles issue. It's very easy and straightforward because we have treated intersection in our relative velocity motion before. So here is just an application. By the time we treat some examples, I believe it will be clearer. Now, please, I want us to see what I was trying to say. We were given this diagram. One moved slanted and one moved vertically. And we are told that collision occurred after 1 second. Find theta and AB. Because they are on the same axis, is the same, which means that for collision to occur, the vertical relative velocity must be 0, because the relative distance as in the vertical distance is equal to 0. The relative vertical distance is equal to 0. Then we'll be able to find this one now. So 10 root 2 sine theta will be equal to 10. So theta, sine theta is equal to 1 over root 2. So theta is 45 degrees. Simple, straightforward. Because it is on the same level, it makes the calculation to be very easy and straightforward. The next thing that we are told is the collision occurred after 1 second. The relative velocity, relative horizontal velocity, is equal to 10 root 2 cos 45 minus 0. You can see. So that is our relative velocity. So distance AB is equal to relative horizontal velocity 10 root 2 cos 45 times time, and that will give us, I believe that's 10 meters. So you can see it's very straightforward, very easy, just like what we have done in velocity, relative velocity, and whatever. Now we have some information here. This one, let's say VA from tower A, which is 10 meters above the vertical, moves with velocity 10 root 2 with angle 45. Another one moves from B, tower B, 10 meters per second towards A. We are told that they intersected in the air. You should find AB. If you look at this, the relative velocity, vertical relative velocity, is equal to, because B does not have any components along the vertical axis, so it's going to be this one only. So VA minus VB, that is vertical, is going to be 10 root 2 sine 45, and I believe that is 10. That's per second. So, relative distance is relative vertical distance is equal to 30 minus 10, which is equal to 20. So with this, if they must collide, this 10 will fill this 20, and it is the same time the two of them must move and meet along this space. So what does that mean? Time will be equal to 20 over 10, which is 2 seconds. Now let's see the relative velocity along the horizontal. Relative velocity along the horizontal will be equal to 10 root 2 cos 45 minus, this one is in opposite direction, minus 10, which is equal to what? 20 meters per second. And which means that they must meet at that same time to fill the horizontal distance. So, horizontal distance AB must be equal to this time 2 times the relative distance 20, which is equal to 40 meters. So it's very easy and straightforward, at least with this. Thank you very much.